So now we need to talk about converting from base 10 to another base. If we have the other base number, we expand it. That'll get us to base 10. However, expanding doesn't work if we have base 10 and want another base. For example, if I want to write I don't know, 137 in base 4. Reason expanding, that is, this isn't, oh, and that brings up another point. The standard rule of thumb is if the subscript is not there, unless it's otherwise noted, but the subscript's not there, it's base 10. So this is a base 10 number. I want to go to a different base of base 4. Well, the reason expanding doesn't work, since this is base 10, these are all by powers of 10. And so if I do expand it, I get 1 times 10 to the third, 1 times 10 to the second, 3 times 10 to the first, 7 times 10 to the 0. That's 100, that's 30, that's 7. I just get right back. It's just a circle. Okay. So expanding doesn't work here. Now if I want to convert from base 10 to another base, I have to use a different method, and that's called successive division. To convert to another base from base 10. It's called successive division. We had something in number, yeah. It was successive duplication. This is not to be confused. Successive division. This goes from base 10 to another base. Whatever base. Just another base. Okay. So here's how it works. I drop, I like to go upward with this one. Start with 137. I'm going to divide it by something. And what I'm going to divide by is the base I intend to go to, which is base 4. So I want to divide 137 by 4. Now, I want to know how many times 137 goes into it. Well, that one's not one I'm totally familiar with. I'm going to just use my calculator. Divide it by 4, 137, I get 34.25. All I want out of that, for now anyway, to go on my division bar there, is the whole number part, the 34. 4 goes 34 times into 137. Now, I also want, I don't want the decimal part, but I do want also to keep up with the remainders. Those are going to go over here to the side of my divisions. What remainder do I get when I divide 137 by 4? Well, it goes 34 times evenly, and if you think about it, 34 times 4 is 136, isn't it? Just multiply those two together, you get 136. So what does that tell me remainder-wise? I'm going to have a remainder of 1. Yeah. Okay? All right, well, it's called successive division, so guess what I'm going to do? Divide by 4 again. 34 divided by 4 goes 8 times, doesn't it? Evenly, whole number. Also, though, I want the remainder, so what remainder would I have? 8 times 4 is 32, so that would be remainder 2. So it goes to the side of the 8. Okay? Divide by 4 once again. 4 goes into 8 2 times. And yeah, this is a good point here. What's the remainder? There's no remainder. Well, the thing is, yes, you do need to keep up with that. If there's 0 remainder, put 0 as your remainder over to the side. All right? Now, I've reached a point. Can I divide by 4 anymore? No, because 2 is smaller than 4. I can't divide by 4 and get a whole number anymore. So I'm pretty much done with that, that part of the process. Now, turns out, here you go. If you start with that last number and then work your way around like so, 2021 is what I would have. Well, that turns out to be the base 4 equivalent of 137. So start with this one and go around like that. If you do it this way, that's your base 4 equivalent. 2021 in base 4. Successive division. Now, let's verify. If we expand this out, what should we get? We should get 137. So let's see. All right, so 2021 base 4. So that would be 2 times the power of 4. It'd be 0, 1, 2, 3 power. Zeros times 4 to the second, 2 times 4 to the first, and 1 times 4 to the 0. So that'll be 2 times 4 to the third is 64. 0 times 16, 2 times 4, and 1 times 1. Is that 137? 2 times 64 is 128. 0 times 16 is 0. 8 and 1. How about that? Isn't that 137? 128, 8 and 1? 137. So sure enough, it works. Okay. All right, so a couple more. Let's write 57 in binary, or base 2. Okay, so I'm going to base 2. So what do I do to convert it? Successively divide by 2. So I take the 57, successively divide by 2. And I should drop down a little lower. Actually, that's going to take more than you think. 2 divided into 57, how many times? It goes 28. 2 times 28 is 56, so I have a remainder of 1. Divide 28 by 2, it goes 14 times. What's the remainder? 0. So I put 0 over there to the side. Same thing on 14. Divide it by 2, it goes evenly 7 times, 0 remainder. Divide 2 by 7 again, it goes 3 times. 3 times 2 is 7. 6, so remainder of 1. Can I divide any further? Yep. Divide by 2 again. It goes 1 time. 1 times 2 is 2, so there's a remainder of 1 there as well. Now I'm done. Can't divide any further. 1 is smaller than 2. So what's my binary number? Well, start at the top and work your way down. 111001. Base 2. Okay? That's in binary, right? Base 2, because it's just got 1s and 0s in it. Question or concern?
Are we not converting it back?
No, I just did that. You don't have to convert it back. I just did that on the first one just to show that it works. I mean, you can if you want to, but you don't have to. Yeah. All right. Okay. Any other thoughts or concerns? All right. Let's do one to base 16. Let's write 3 3,263 in base 16. So I'm going to successively divide by 16. 16 divide into 3,263. How many times? I get 203.9, so it goes 203 times. What's the remainder? How would I get it? Well, I'll take 203 times 16, don't I? 203 times 16 is 3,248. So what's the remainder here? Well, 3,263 minus 3,248 is 15, isn't it? Remainder of 15. Is everybody okay on that? With me on that? Okay? Okay. What do I do now? Divide by 16 again. 16 divided by 203, or 203 divided by 16 actually, goes 12 times. What's the remainder there? Well, 12 times 16 is 192. So my remainder would be 11. Is that right? Okay. Now, the catch is on bases higher than 10, we've got the letter thing here, don't we? What did we say? These were, A is 10, so forth and so on up from there. So I need to convert those back to their letters, or convert those to the letters, right? A is 10, B is 11, so this one's B, isn't it? 12 is C. What's 15? Well, 13 is D. 14 is E. 15 is F. CBF? Base 16.
So why did you want to put that on there? Just because they were past the 10 higher than 10?
Yeah. Yeah. When we get to base 16, or bases higher than 10, are there's those letters. A is the 10, and so yeah, if I have 12, it's represented by a number. C in this case, because A is 10, B is 11, so it just goes up. All right. Now, I saved this one for last because it's sort of a little confusing at first anyway. But let's think about this process just a hair more. And we count when we're learning our numbers. We count a lot when we do that. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. We learn that a lot. But let's think about counting in other bases. Let's write the first 15 counting numbers in base 6. Now, when I say counting numbers, I don't start with 0, right? Even though in our number system we have 0, when I say counting numbers, I start with 1. And I say that because that's what the book does. It starts with 1. 0 is a base 6 number, but If I'm starting with the counting numbers, it starts with 1. So I'm going to leave off 0. I'm going to start at 1. 0's in there, but I'm starting with 1 because it's counting numbers. All right, so anyway, the problem is, yeah, I start perfectly fine, 1, 2, 3, 4, 5, but I hit a snag right here because I'm talking base 6. And what are the symbols in base 6? 0 through 5. There's no 6s in base 6. Why not? Because you only need 6 symbols in base 6. And 0 through 5 are the 6 symbols. Right? So I don't have any 6s in base 6. So basically, one way to think of it is I've run out of 1 digits that I can put up here now. Because I can't do a 1 digit of 6 now, or 7, or 8, or 9. What do I do? No, not letters. We only use letters if where base is bigger than 10. Base 6 is smaller. Good try, though. Now, in base 6, if you think about it, if I'm in base 10, I get to 9, what do? I go to 2 digits. It just so happens in base 6, I go to 2-digit numbers more quickly than I do in base 10. Yeah, since I don't have any more 1 digits, right? I can't do 6 or 7. I have to go to 2-digit numbers. And what would be the smallest 2-digit number, do you think? It would look like 10, yes. 1 0. I don't say 10 because it's not equivalent to our 10, but yeah. You see that? Well, which one is 1 1 smaller than? Is that what you're saying?
Yeah, well, how come it's not going to be 1 1 and then 2 2?
Oh, okay. Well, what it amounts to is if you think about it, if you wrote 2 digits for 5, it'd be 0 5, right? So really, what I'm doing is I'm increasing this digit by 1. You see? Does that make sense? Maybe it doesn't. Maybe that made it more confusing. But no, what's our first 2-digit number? If I'm regular counting in base 10, what's our first 2-digit number? It's 10. In every base system there is, the first 2-digit number is 10. 1 0. It's always 1 0 for the first 2-digit number. Then the second 2-digit number will be 1 1. Then what will be next? 1 2. 1 3. I'm okay until I get where? 1 6. Do I have a 1 6? No, because there's no symbol of 6 in base 6. So I'm stuck at 1 5. What do? I go to the next level of 2-digit numbers. When we get to 19, where do we go? We go to 20. 2 0. Then we're okay. We can do 21, 22. I need 15, so how many have I got? Got to go 2 3. Okay. So that's 15. Huh? That's how you count in base 6. You don't have 6 in base 6. So you have to go to 2-digit numbers once you get to 5 or after 5. You just have to start the 2-digit numbers after 5. Okay. You just run out of symbols earlier. That's what it amounts to. I mean, why don't we have another symbol after 9? We just don't. Okay. Just the way it's set up. Probably because we have 10 fingers and 10 toes is why we have base 10. But what if it had been base 20? Well, maybe we would have I don't know, but